This week's assignment is going to be focused on a heat map and converting some code into a function. So this project was part of this open source football where Ethan Douglas looked at some data. He has it scraped using a web scraper from the next gen stats, and as a result he can look at some of the quarterback data over the last few years to create some really interesting visualization. So as we go through this, these are the packages we're going to need. You see that this is the DF that's coming from our his GitHub, Arrowhead Analytics. He drops anything that's missing. We see how many total. There's 37,000 lines here, rows, and we can see some information about that. Obviously, there's 16 weeks in this. It looks like it's max of 20, so there's 20 weeks, so maybe this goes into postseason. Then we see that he starts to use some visualizations, this distribution plots, which is like a histogram. You see from 0 is the 0 is our snap point, passes from the to the left, passes to the right, and then we also see how far downfield these passes are occurring. So again, 0 to the 10-yard line, that's the majority, and then you see that some of these passes all the way down. He takes this, then there's a joint plot, which will then take both of these, stack them across each other, and create a lot of scatter plot points. The scatter plot points, obviously, that's chaos, so they use this kind.hex, which kind of groups them using a reduced opacity and seeing kind of where these points are occurring and what frequency, and you start to get a sense of like a heat map versus a scatter plot points, right? So there's not any understanding of obviously I think that the more dispersed they are, the less frequent, and then the denser they are, but it's hard to tell when they're all stacked up like this what is actually happening. So we start to see that. Then we see him use this kernel density estimate, which takes the same kind of idea, but it then draws kind of what I'm referring to as topographical lines, or like just lines based on these groupings. And it's really interesting that it does this, is that it what you'll eventually see is that you can then fill those shapes with different opacities, just like you would these points, but then you're going to see kind of ranges where obviously in this particular chart, which is all the quarterbacks, all 37,000 points, you're going to see that there's a high density that are passes kind of in the midfield within my snap point to the 10-yard line, so kind of right in front of me. Maybe that's a tight end pass or whatever that might be. So it's going to do this. We're also going to see that then he takes these and puts them side by side. One is with another quarterback, Carr, and he compares that to Kyler Murray. And so all of this code here is a Matplotlib where we see side by side plots, and one of them is going to be, here's our chart again with the topographical lines. As I said, this is our KDE type, which looks like that. This is again for all 37,000. Now we're going to see it filtered for these two particular quarterbacks. So where in the data set in DF do I see the name in that? So Carr, show me those points, and then it's showing all of them for all the seasons. It's showing them for all of passes, complete or incomplete, and we get to see kind of the disbursement of where the quarterbacks are passing. Both of these are using the color map reds, and you see this CMap reds. Okay, so then he did this, but he did it using a mock-up. Same thing. We see that he's got two side by side. One is going to show Newton. Same exact thing, but now we've got this chunk of code here where he's going to plot the field markings. Yep, and actually, then we see the next quarterback here, and now we should see them side by side. So I compare Cam Newton to Russell Wilson. Where are they passing the ball? In what frequency? All right, so I haven't done anything yet. This is, again, the code that was provided to you. This is the code that gets the output that we want, right? So, but we want to do it. We want to create a function that could be any quarterback we provide that's in the data set, and narrowed by season, and changing the color maps. So how do I do that? I'm going to create a function, right? So when I think about functions, functions look something like this. So I'm going to make like an area, my area, right? How does a function work? So area is side by side 1 by the side 2, right? So these are going to be, this is what my area function does, right? So area is equal to side 1 times side 2. I'm making a template that I can use not just for set numbers, but I can use for any number, right? So I could say, now I've got my function set. My area is now, I want to see what 4, 10. What is that going to look like? And it's going to go through, side 2. So I've got those values. So now I see 4 times 10, but I can call that, I can do a lot of these, right? So I could say 4, 5 times 8. And it doesn't need to change anything in my function. My function is the template, and it's going to go through and get me whatever those outputs are. And that's what we're going to do here, but with our quarterbacks. So if I think about this as my sample, I'm going to do the same thing here. So I need to get what's happening in my function. This is my quarterbacks compare. Right? So comparing the two, I want to see them side by side. What are the things that I'm going to need? And if I look at how it's going to get called, I see here Brady, Mahomes, a season, and the color map. So my CB1, QB2, the season that I'm in, and the color map. All right. So that's how the function is going to be written. I see what parameters are here. When I try to call my function, again, this is what it's going to need to look like. Copy this. But now I need to replace the template parts with specifics. So Brady, Mahomes, 2018, and then the color map is again on a list. There's reds, blues, greens, and it's all going to be a sequential because again, the more that's happening in a particular area. And then I paste the same thing, change my season, and change the color. I want to see this in greens. Now when I run this, obviously nothing's going to happen. I have no values in my function, but that's what is going to happen, right? So if I said these values won't go in here, they're not being used. So how do I change that? I'm going to grab the code that's up here, put it in my function. It needs to be indented because that's part of the function. I know that this is all part of that function. Okay, so if I run it, it's going to give me, again, I can run it here, run my cell, come down here, run my cell, okay, cool. Run my cell below, okay, cool. And now it's going to say Newton and Wilson. Newton and Wilson. I said Brady, Mahomes, and Greens. How come I'm still seeing those set things? Well, our parameters, QB1, QB2, season, are not being used anywhere in this function. So I need to find where QB name 1, this is now QB1, where my other quarterback is, Wilson, this is QB2. Again, I'm just calling them that, but you could call them whatever. You could call them left and right because they're going to be in left and right positions. That's up to you. CMAP, I want to put my CMAP here where it says reds because I want to be able to change that from other things. So let's do CMAP is equal to CMAP. Same thing on the next chart down. CMAP is equal to CMAP. And let's run it again. So I've defined my function, run my example, and let's see what we see. Brady, Mahomes, reds, Brady, Mahomes, greens. All right, so I'm seeing them and I'm seeing the color. Cool, so I'm really close. So I just need to figure out how to get this season parameter to do something, right? So I want to filter this data frame where I'm seeing my the season, right? So I want to say can do like a df equals df of the season column is equal to the parameter that I'm passing, season. All right, let's run that. All right, and I run my cell down here. Let's see what it says. All right, df is not referenced before assignment. So maybe I come up here. Where's my df? At the very tip top, right? I copy my df. So now it's getting assigned here. That's my normal DF. Now I'm filtering it down to where that particular season value is being passed. I'm filtering it with the name of this quarterback. I'm looking, or not filtering, but I'm creating a data frame with just that values. And now what I should see is two charts. One that they're both the same quarterback. They shouldn't look identical because, again, their passing positions are different. You can see that they're similar, right? In just like the heat map shapes. This kind of has like two little shapes like here, and same thing here, because that's the kind of player he is. But they're not identical. We can tell that they're not identical, and that's all you had to do. We made the template. I defined the template, what's in it. I then used my values in within my template, right? Where's the season? Here's season is equal to season. The CMAP is being replaced wherever it's using CMAP. So I can come down here. I want to do it again, but I want to pick a new quarterback. So I'm going to copy this. I know the list of names of quarterbacks. I can look that up pretty quickly, right? Quarterback, maybe DF, name, unique. Show me all the quarterbacks. Okay. So I want to compare, in my example now, maybe I want to do Roethlisberger, kind of classic quarterbacks against each other, Rodgers, and I want to see how they pass against each other, or not against each other, but comparing the two in this season, 2019, and I'm going to do it in blues. So I don't need to change anything in my function at all, because it's taking these values, substituting them in where I had the references, and I get to see something like that. If I want to see, maybe I want to see them compared, year to year. So I would do like that. And now I say 2019, 2018. See how they look using those data. How do they pass differently in these 2 years, right? So you still see a very similar shape. They're not the same. You can tell that this is wider. This one's a little bit smaller than this shape in 2018. The shape is elongated here, and it's a little bit denser in this position. But I can do that and customize it really quickly because I've turned it into a function. So that's all you had to do today, and good luck.